In this slide, we'll be looking at the background processes and what they do inside the Oracle instance. Of course, we already know about PMON, we know about DBWriter, we know about LogWriter, and we see there are 3 new processes in this slide. Let us start with SMONn. SMONn is nothing but it's a system monitor background process. It helps in instance recovery. What is this instance recovery? Whenever a database is running and suddenly somebody shuts down the server or suddenly there is a power failure, then the instance will crash because there were some transactions which were going on in the memory, and in such cases the instance is said to have a crash. Now when you start the database again, the database has to recover the instance, right? Now, after a crash of instance, when Oracle automatically performs the recovery of instance, it is known as instance recovery. This will be done automatically. DBA has nothing to do with the instance recovery. You don't have to worry. Oracle takes care of instance recovery automatically. But as a DBA, you should know what is an instance recovery. Ultimately, the SMONn, it's a background process which will take care of the instance recovery if there was a crash of instance. Next, it will coalesce the table spaces which are defined as automatic segment space management. Inside a table space, you save lot of data, you delete lot of data. What happens is it will create the empty pits or empty spaces. You have a continuous storage, but in between you delete some rows or delete some data, it will create some empty spaces, right? Those small empty spaces are not enough to store the new data. What table space coalescing will do is it will combine all those small empty spaces within the table space to create a big free space. Now the big free space can be again used for storing the data. This is nothing but called as coalescing. SMONn will take care of coalescing of table spaces when you perform the database startup. Whenever you start the database, it will go ahead and check the table spaces. Wherever there are empty pits, it will combine all the empty pits or empty areas into one big free area so that it can be used in future for storing the new records. Next, SMONn will release the temporary segments occupied by the transactions when they are completed. We know that inside database, queries will use the temporary table space for sorting purpose. Once the transaction is completed, SMONn will release those temporary segments. That means it will allow the temporary segments to be used by other users or other queries. Now that is also the job of SMONn. It will release the temporary segments which are held by any user transaction once the transaction is completed. The next process we already know is PMON. It is responsible for following actions. Releases the locks and resources held by abruptly terminated sessions. Oracle internally works with a concept called as locks. What are these locks? In simple terms, when a user is trying to modify a table, another user should not be allowed to modify the table because first user will have a lock on the table. Primarily, when any user is trying to update any data inside the table, it will first hold a lock on the table so that other users cannot update or modify the table. Once the transaction is done and user commits the transaction, the lock will be released. Once lock is released, other users are free to again hold the lock by trying to modify or delete the tables. What PMON will do is, let's take a user connected to database and it is trying to modify a table, but the user connection got terminated suddenly. Probably the user machine got shut down, or there was some network issue, or maybe some other issue. In such cases, PMON will release those locks which were held by the terminated session. This way, the other users can go ahead and use the data or play with the data. Next, PMON will authenticate the user We know that whenever there is a new user connection, PMON will actually authenticate the user. Next, PMON registers the listener information with the instance. Whenever you create a listener, the listener information is registered with the Oracle instance via PMON. See, if the listener is not registered with the instance, how would Oracle know that from which instance we have to accept the incoming connections, right? There might be multiple listeners in the database, or there might be multiple database instances. Then which listener belongs to which instance? There should be some registration. This registration of listener with the database instance is done by PMON. Next, DB writer. We already know that DB writer will write the dirty blocks from the write list to the data files. It is responsible in writing dirty buffers from write list to data files, and it will do this action in following situations. After log writer writes, when write list reaches threshold value, at every checkpoint, when table space is taken offline or placed in read-only mode, and when database is shut down cleanly. On all these events, the DB writer will write the dirty blocks from the write list to the data files. But ultimately, if you look at all these events, even though these events will occur, DB writer will always write after the log writer writes, because transaction recording is more important than execution of the transaction. Next, log writer. It is responsible for writing redo entries from log buffer cache to redo log files, and it will perform this in following situations. Now there are some events at which the log writer will go ahead and write the redo entries from the log buffer cache to redo log files. Before DB writer writes, we already know that whenever commit occurs, if a user issues the commit statement, then the redo entries will be written from the buffer cache to redo log files. When log buffer cache is 1/3 full, or when 1 MB of redo is generated, and every 3-second checkpoint event will occur. On all these events, whether the log buffer cache is 1/3 full, or when 1 MB of redo is generated, or at every 3 seconds whenever there is a checkpoint event in the database. Now the question is, what is this checkpoint event? To understand this checkpoint, it is kind of a wake-up alarm for the Oracle instance. At every 3 seconds, Oracle will issue a checkpoint event. This checkpoint event will tell, can you execute these steps in series? For example, if at every 3 seconds the checkpoint will occur, right? The checkpoint event will tell instance, okay, can you write the redo logs in the memory to the redo log files? Done. Next, we already know that when log writer writes the redo entries to the redo log files, DB writer will go ahead and write the dirty blocks. Basically, it is an event to make sure that anything that is kept in instance, it is made permanent to hard disk immediately. Understand, if we do not do this thing, then if there is a crash or instance crash, we will lose all the data which is there in the memory. It is very important for Oracle to save the data or ensure that everything is returned to the hard disk as soon as possible. That's why there is a 3-second checkpoint event inside the database. This checkpoint event will make sure that, okay, redo log files are written, the dirty blocks are written, and even it will trigger other events inside the instance. Once again, the checkpoint event is kind of a wake-up alarm. It will make sure that things are made permanent to the hard disk as soon as possible. This checkpoint event will occur by default at every 3 seconds inside the database instance. Ultimately, the log writer will write the redo entries on following events: before DB writer writes, whenever user issues commit statement, when log buffer cache is 1/3 full, when 1 MB of redo is generated, and at every 3 seconds when checkpoint event will occur. Next, we have CKPT background process. This is again checkpoint process, but don't get confused between checkpoint event and checkpoint process. These two are completely different. It will update the latest SCN to control files and data file headers by taking information from redo log files. This will happen at every log switch. Now what is this log switch? Nothing but if we have two redo log files, when the first redo log file is full, log writer will start writing onto the second redo log file. This switching of log file from one redo log file to the next redo log file is known as log switch. Now at every log switch, what will happen is checkpoint process, it will update the latest SCN number to the control files and data file header by taking the information from redo log files. Next is archiver process. When we say ARCHn, N means we can have multiple processes. The same way we can see that DB writer has DBWRn, and also we can have multiple SMONn processes. We have SMONn. The archiver process is nothing but it will generate the offline redo log files in separate location. This will be done only if database is in archive log mode. Do not worry, we'll understand about archive log files in some time. For now, just understand that archiver process is the one which is responsible to create the archive log files inside the database. If you look at the database architecture diagram, the archiver process is just created outside the instance. Ultimately, it is part of the instance, but why it is created outside the instance? Because archiver process will come into picture only when it is enabled. If you do not enable it, then definitely it won't come into the picture, right? So that's why don't get confused that archiver is not part of the instance. Yes, it is the part of the instance, but it has to be specifically enabled